Hello, I welcome you to this very segment. We'll be discussing briefly about single linked list, and this is not really to crack the whole thing down, but to aid your understanding if you've read something before and find some things confusing. You know, if you read about it, or if you're yet to read about it after this section, if you go back to the concept page or whatever, or some of the resource materials that you were given, you will you will grasp it better. What is grasp again? Oyibo. Okay. Single link list. You need to understand that uh, um, it's a kind of data structure. Is You may have heard of something called ADT, abstract data type, right? Abstract data type. Now there are. Let me do it this way. Abstract data types. Let's build on this now. Let's build on this. First of all, there are primitive data types, right? You want to understand data types. There are primitive data types. You know them very well. They were talking about those guys, those your brothers and sisters, and car float. All right. So this one, the first one has to do with whole numbers with no decimal points, decimal place, and this one float has to do with um, numbers that have decimal points, decimal values, that makes 2 and 2.0 not to be the same thing in C. And so car could be anything. Yes, I dare say it could be anything because from A to Z, I mean lowercase a to lowercase z, uppercase a to uppercase z, 0 to 9, all the characters, question mark, hyphen, each of them, any one, even space is a character. Okay, so and then we have derived data types as well. I called this one primitive data type. Let me make that clear here. So primitive data types. In LX, they build on what you know or what you've learned. So if you didn't learn something in the past, it will affect some projects in the future. All right. So we have let me give this some heading. Call it data types in C. Data types in C. Data type. What is data? Data is what layman definition would I give now? Data is some anything represented in text, or in this case text. We're not talking about images now or some files. Okay, so that thing that is inside there, whether it's number or letter or words, is the kind of data. But what type of data it is it? What type is it? So that's what we refer to as data type. So if I go primitive data types now, derived data types now are those ones that ordinarily they were not there. They were not there, but something had to be done to get them. Who's a meter? Can you meet to my place? Derived data types. And I think arrays are derived because there is no data type like array. It is still int. It's borrowing for int or float, or depending on what is there. So it's not part of this. When we say primitive, something is like going to the root, the smallest form of it, where it all started from before we started having improved type of it, or higher, better type of it, or more sophisticated kind of it. All right. So array was derived. Even the string is derived. I mean, in Python, for example. Oh, sorry for mentioning Python. Several tutors make this mistake of referring to other programming language when they are teaching. So me now, I don't want to start making that mistake, knowing what it feels like to be a newbie and someone is making reference to something you don't know. He's trying to teach you and he's making reference to something you don't know. So let's keep that apart aside. All right. So strings is derived because you don't have any data type called string. It is sticker. You derive it from here. So I think it's derived. And then now we have um, um, another thing that makes you structure data in a manner that is originally not possible. So we call this one data structures. Data structures. Okay. Now we also have abstract data type, right? When we say abstract, we are talking about, of course, what does abstract mean? Someone should talk now. I think the only one talking. When we say abstract, what comes to your mind? Something is abstract. What comes to your mind?
Abstract, abstract is abstract.
Interesting. She said abstract is abstract. So no one got any other thing to say about abstract?
Like it doesn't really have any particular how will I put it? It doesn't really have any particular form, dimension. Like can't really pinpoint and say this is what abstract is because it's the way I conceptualize it is going to be different from the way another person conceptualize it.
Conceptualize your own analysis now.
That's just like it's I'm not talking of the definition now.
Yes,
It
just tell us
just
something about it.
like it's a thought. Abstract is a thought. This
Oh,
is what I'm trying
that's
to say.
heavy. That's heavy. Abstract is a thought. Abstract doesn't exist. It's just in your mind. This is powerful.
Yeah.
So I think this. I mean, for me, it's about us trying to understand. Uh, Try to understand this in such that we can say it in our dialects. We can use our own words to describe it. That's I've never seen anybody describe it like that. Abstract is a thought, right? But it's something you're imagining. You're creating a picture somewhere that does not really exist. So when we say abstract data type, single linked list is some abstract data type. And if you read several resources, they will make you see that it has a structure like this in memory, something like this. Um, so let me duplicate this. Have it like this. Uh, like this. Let me just have a single linked list with 4 nodes. These are all nodes, right? Let me use this to represent the head. If you don't know what I mean, don't worry. I will explain that as we make progress. So let me use this to represent the head. And single linked list is actually scattered. It's not arranged like this, scattered in memory, and that's why the memory address of each node is not progressive. It's not such that it's not sequential, right? Okay. Now let me first of all represent. Let's start from array. I want to believe that you know what array is, or you have an idea of what array is. Let's begin from array. Arrays, you use array to structure data. So let me try to make a pictorial representation of what array looks like in the computer memory. All right. Let me draw this. So let's say these are bytes in memory. 8 bits make a byte. So those are different bytes in memory. And you know how we declare a string. I want to declare a string that contains my name. Somebody unmute and tell me how. I want to declare a string that contains my name.
Sure.
The board is getting wrong for me. Yes.
Sure. Then the square brackets. No, ch.
What?
Uh, put the name space
Namespace.
of the square brackets.
Square brackets. Like this. Okay.
Yeah. And what's your name again? Top man. Can you put six inside?
Inside the square bracket.
Yes. Six.
Okay. Oh, 6. All right. Next. Is that all?
Semicolon. Semicolon.
Semicolon. All right. So I don't know why you should have space between uh name and the square bracket.
No,
I'm trying.
the
I
space
don't.
is in between the char and the name, not the square bracket.
Okay. 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 All right. So and then you have Topman here. So this will work, right? And semicolon. So when you do this, what happens in memory? In fact, if we had done only this, let me take this off. Okay, let me take it off from here and leave the semicolon. Stay there. Let me cut it off. If we had done only this, what happens is at random, some memory blocks of memory will be allocated to this variable to save it in the computer. And you know that the size, now each character has a size of 1 byte, contributes the size of 1 byte, occupies the size of 1 byte in the computer memory. It's not a joking matter. It's true. It's a serious matter. Let me get this my terminal out in case I need to do some coding. But basically, I've come to do whiteboarding for today. I mean, it's important to do whiteboarding. It's very important. See, when Elias is taking us through all these things like this, it's not for nothing. No, it's not for nothing. It's very important. Okay. Um, let's make progress. So what happens to the block of memory is that something like this. Let's say, let me pick my eraser. It will not go here and make space of 6 bytes because you said that the size of your array is 6. Sorry, yeah, size of your string is 6 actually. It's still an array of characters. So 1, 2, 3, 4, 5, 6 bytes. It will make this space for this particular variable. Let me copy this. Um, hey, stop that. I thought control this for copy. All right. I'm going to reduce it so that it will take this space. So it okay. Let me just use the name because that's what actually. So the name of the variable is name. It creates a space in the memory for name. Hope this is clear enough. Yeah. Hope it's visible enough. Name. Now it has given name 6 bytes. This is what happens. Since there's nothing there, there's not you've not initialized the variable. You just declared it. There's nothing there yet. So this is how it is. How it looks. If you now go further and put something inside the name, hey, leave here. Okay, and put something inside the name. Let me put back what I cut before, like this. It will now come here. Let's say this space is a variable. This space is for what. It will now come here and add. Or where's that guy that I kept here? Come here. Oh, be smaller. Each 1 byte now we have be holding the first byte will hold T, right? And since an array is sequential such that since it's 1 byte, you can add 1 to get the next member. Okay. But what I'm trying to illustrate is how that if you add 1 to the memory address to this one, if I had some more time, I would have done that. Honestly, I would have done that. Why it is not here yet? I would have asked him to continue from there. So 0 here. Oh, I mean to say P here. Let's make this longer a bit. And M here, A here, and N here. So this is how it happens, right? In memory. But for this guy is scattered in memory. It's scattered. It's not really like this. So just scatter different nodes at different places, such that you can have uh, uh, this is the head. You can have this as the first member. You can now have let's say this as a second member, and you can have this as a third member, and then you can now have this as a last. Remember. Now, the structure of uh, uh, a single linked list, the structure of the node. This is called node. Node, Node. Node. So the structure of the node is like this. It has the data, the information that is carrying, and then it has a pointer to the next one. So there will be a pointer here. Let's call it P. And then there will be some data here. That's the way it is for all of them. So there's a data here. Let's say it's a list of the score of biology students. So this data could be uh, um, um, the name of the child, the and the score. Yeah, the name of the child and the score. Name, maybe name, class, score, or something. Let's say name and score. Name and score is fine. Name will be string, score will be integer. Okay, so this will be a pointer. Remember that pointers have the memory address of the variable that they point to, right? They hold the memory address. That's what is stored in pointers. Memory address. Okay. Okay, this is the last one. So it not be pointing. It will not be pointing to null. Null. What does null mean? What does null mean, please?
I think no kind of signifies the end of something.
The end. Okay. Thank you. Does anyone have anything to say? Anything else to say about what null means?
I
In
think
this
no
case,
means
like zero is not pointing to any
is
particular
zero. Yeah, no,
address.
it's zero.
Okay, Ugochunye, you wanted to say
It
something?
becomes zero. Yeah.
like it's empty. When it's null, like nothing is inside. That's what
Okay.
I understood by null in this scenario.
Just an empty file. That's it.
Mm.
Remember that we have something like this backward slash zero
Yes,
in
that one is the
C
end of a
programming.
string.
Okay. This guy is actually a pointer to null. That's by the way. That's by the way. Okay. So the head itself is a pointer. It has the address of this first guy, this visitor here. And so I think I should draw this very well. I should draw this line very well because it's actually pointing to this data here. So it should be pointing to this place. Yes. And then this one is the pointer. It's pointing to where? Oh no. What is happening here? These lines are wrong. Let me let's make it. They should be. I want the illustration to be accurate so that when we go into coding, it'll be much easier to understand. Hey, I've cleaned what I want to clean. Oh. Mm. Yeah, no, go. Instead, go. Okay. So the way it is that this guy, this pointer now is pointing to the next one. I'm intentionally scattering it, right? Let's say this is the next one. It's pointing to the data. It has the address of this data stored in it. And this one now has its own pointer pointing to the third one. Let me make this the third one as well. So it's pointing to this data. And this pointer of this particular node again has its own pointing to the last one. And the last one, of course, is now pointing to the to null. I mean, it does not have anything like someone said it's empty. And then so I say is zero. Someone else say is the end. Did I hear that? I don't know when I heard that. Okay, I think my time is up for now. It's up for now, and Mr. White is not here. We'll continue some other time. The board is here. Continue some other time. Anyone get to the question? Okay, I encourage you to go and read up what's it called now? Some concepts and terminologies that are associated with single linked lists. You should know about struct in C, struct and type def, and that's not hard. Just read something. It make it easier for you to understand. Struct, type def, what's it used for, as it used, and then you should know about those terminologies, those things, those are operations that can be carried out in a single linked list, such as transversal. Yeah, what is transversal? For what are the types of single linked lists? What are the difference? So read about the types of single linked lists. Read about border operations, deleting, inserting, insert at the beginning, things like that. Read about them. You will do yourself good if you read about them. It will make our next flow very much better. Thank you very much. Now, see ya. I wish I had it an appointment. I would have continued, honestly.